This is a rotational equilibrium problem for Physics 2100. A 750 kilogram transformer rests 0.9 meters from the left edge of a 3.5 meter long, 350 kilogram steel beam as pictured below. The beam is supported at both ends, the left and the right. We need to calculate both support forces and check our answer. The two equations that we need for this problem would be force equals mass times acceleration and torque equals force times the perpendicular radius. To start this problem off, we would start by thinking sum of forces, which would be the force of the block, the beam, the left and the right end, because those are all of the forces acting on the diagram, and they would all equal 0. These are both negative because they're working in the opposite direction as the left and right. After we go to plug in numbers based off of the question, we would start with the mass of the block times acceleration due to gravity and the mass of the beam and acceleration due to gravity. And then we would keep working and we would get to a point where there are two unknowns. At this point, we have to switch to sum of torques because we can't solve for two unknowns. For sum of torques, we can pick any point on this beam and it should equal 0 because it needs to be in rotational equilibrium. I chose to pick the sum of torques based off the left end because that would make the distance from the left point equal to 0, which means the torque at that point would equal 0. And so to start this problem off based off the sum of the torques, I did the mass of the block times acceleration due to gravity times the distance away it is from the left end. And then I did this for the other one because gravity acts at the center of the beam. And then I did the force of the right one, which is 3.5 meters away. And I set them all equal to 0. And then I did some algebra and I got that the force from the right end has to be 3,600 newtons. To solve for the left end now, we would go back to the sum of forces and we would plug in the right end in the equation, and then we would solve for the left end, which is 7,200. If you wanted to check your work, you would simply do the sum of the torques based off the right end. And to do the sum of the torques based off the right end, you would change the distances to how far they are from the left or from the right end, and then you'd solve for the left end, which is 7,200, and then we plugged it back into the force equation and got the force from the right end is 3,600. So that means that we were right.